appears frozen. For CS3IIN, so when we increase the pulse duration, what we are able to see that we are actually able to populate highly charged states, and we are seeing highly charged states. So more details again can be found in these two papers for those. So now let me take you to the journey. So this was one of our, since my my PhD days, I always wanted to make devices, and that is what I am trained also. When I joined Bhas Bapat in my during my PhD days, there was nothing in the lab, and we started from almost from this flat ground, and we built the setup from there. So I'm trained to make setup. So that I'm trained to make instruments. So then that time I was actually trying to understand, can we actually translate the whole thing, whatever I am doing, can we translate to the society, because I belong to the because I like to do some technology. And then fortunately God gave me an opportunity to join the Technological Institute, where we are encouraged to develop technology. So we from 2018 we started translating it to the society. The very first equipment which we made was the whole slide imaging. It is nothing but is just the microscope. If I say just the microscope, but it does a lot of things. It has auto focusing. It has 4 objectives in there, and you just push in the slide and it will do all the job. You don't have to really focus it. And then, so whatever slide you put in, so the whole scan it will actually put on the cloud, and then doctors can sit anywhere. They can actually look at the data from anywhere in the world. And this is dust-free device. And what actually made it dust-free, because we have actually logged it inside the optical tube where the dust cannot enter in at all. So in the next here I will show you the movie where actually no, it's not. It should run. Play this one. No. So here it should come. It is. No, it's fine. It is fine. So here you see that this is. So this is the slide which we have inserted, and then you can move up and down there, and it can auto focus. And then along with that, what we can annotate the device, the area, the infected area, the cancer sites and all. So these are basically designed for the biopsy sites, and you can actually annotate it. And we are actually trying to implement the AI as well, so that doctors just have to look at the slide. They can zoom in, they can zoom out, and whatever, they can keep revisiting it. So we don't have to store the slide forever. So you scan the slide, and and then after that it can be stored forever. This data can be stored in the computer. So now the other device which I was actually talking to you about, for which we got grants for. So the idea came during the COVID time, where we wanted to really be wanted to have a minimal contact with the patient. Basically, the health workers should we were not allowing them to go towards the patient, which are the infected patient. So how can we actually do the IV, and that is the idea where actually it came from. So in addition to that, when we were actually pitching for that, so this is when we looked into the data. So this is the kind of when a health worker gives a IV, the failure rate is something about 27%, and it increases in cancerous and the geriatric pediatric patients. I mean, it can go up to 47%, and this increases when the first time if the failure happens, the nurses get stressed out, and then with the human error it can increase even further higher. So if the error happens at the first time, the second time making a mistake is more higher. So this is how actually it happens. So Yeah, so the idea of this one is nothing but is basically we change the light source here. Light source is the near infrared, because just looking at this I am not able to see my veins, right? So but we should be able to see the veins, we should be able to find the depth of it. And with our two eyes, so I mean if I would have the only just one eye, I won't be able to perceive the depth. So because we have the two eyes, so that's why we are able to perceive the depth. And that is the principle which we want to implement here. So we want to use the near infrared light along with the stereo imaging, and then the data from here can be fed to the robotic arm. So this you have the two camera, what you see here in the middle there is a infrared light, and this is me sitting during the COVID time, we were imaging that. So this is the vein which we saw, I mean then, and this is the overall schematic of the setup. So when we get the image, so we need to the image which we get, this is the original image which we got. So we had to do a lot of processing, a lot of Fourier transform. There are a lot of mathematical tools which exist. So this was just for the one image which we were able to pre-process the data, and we can actually process the image. And after that the biggest challenge was to really how to find the depth out. So then there was a key point matching algorithm, so where we have the stereo two images, and we try to match the points, and then with that we can actually get the depth as well. I hope so it is there in the movie. So in the very first, this is how the workflow is. We have the stereo images, we extract the region of interest, we extract the vein structure, we generate the depth image, and then that when we have this depth, then this 3D, we do the 3D reconstruction. This data will be fed to the robotic arm, and the robotic arm will be doing the job. And this was the first. This is our second version. Prototype was already built. This is the second version. It is not yet tested because it needs human intervention. So that's why we did not. I mean, it is still under a lot of testing as of now. So I will show you a movie here. I hope it runs. Yeah. So this is how the equipment is. Over here you can insert your arm. So you can insert the arm here, and then there is the syringe or the needle, whatever you can insert over there. So the imaging will be done by the cameras here. We get the stereo images there. Once the scans are obtained, we get we pre-process it, and once it is pre-processed, we get the depth of it. This is the 3D depth. And once we get the 3D depth, that depth information is given to the robotic arm. This robotic arm goes and actually does the IV. So this is how the setup looks like. Yeah. So with this, I would so this whole work could not have been completed without my team. So this is quite a big team, but all of them don't work in just one area, so there are lots of experiments along. So I use TIFR facility, I use their laser system, so most of my experiments are set up there, the fundamental experiments are set up there. In IIT we do most of the equipment development studies, and yeah, so these are the guys who are working in IIT. This is the top ones, they are working in TIFR. So these two are already graduated. They are actually, one is in Imperial College of London, one is in Max Born Institute. Yeah. And I would also like to thank the funding agencies, IITH, MOE, SPARC, CERT, DSIR and Shri PVF for that. And yeah, and thank you all for listening to me.
Thank you, Professor Vandana, for that truly interesting talk, because
thank you for that really interesting talk, because it's one thing to talk and another thing to walk the talk, and you've actually demonstrated that you can do both. The session is open to questions from the audience. Yeah. Please wait till you get the mic. And
Good evening, ma'am. As I'm a student of B Pharmacy and I'm in this is my final year running out. So next year I'm into the R&D, research and development. As you showed the picture of IV infusion through the injection, if any error reading is there in the machine, how could we know the patient weight, the blood flow of the patient is correct or not?
So okay. So we are also trying to in the next generation, what we are trying to implement. There is a pressure sensor as well, and there is a flow meter as well, which we will be actually implementing there, which can actually measure the flow as well. And in addition to that, I mean, there can be an error. So there can be, I mean, before we do the IV, there will be a calibration process which will be going on. Okay. So if that is actually correct or not, we can actually test it on the phantom first.
Ma'am, my second question is, as the machine is as the construction of machine is all right, and how that injection will be injected to the veins and the blood flow will be correct, and how the caliber readings will be there. The caliber reading will be digital or digital.
Okay, so the amount of the solution which so I think that device already exists. The amount of amount of liquid goes into that or not. I mean, how much amount actually goes into that. That device already exists. So we are not making we are not working on that part.
Okay, thank you.
Thank you for those very nice two different topics that you really talked about. I had some questions about the first part, because long ago for my PhD I did atomic alignment, collision dynamics, Steve Leone and others. So one thing is you talk about the dress states.
Yes,
there.
yes.
And so when you dress the states, your potential curves are also modulated.
Yeah, so they are modified by 1 photon energy down there.
Right. So would it be really, I mean, but in what sense is it then a semi-classical treatment? Because you are necessarily having to look at a full quantum coupling calculation.
No, we semi-classical in the sense that kind of study, the kind of modeling we develop. So it definitely requires quantum mechanical calculation, which we are not expert at. We definitely need help.
Of course, these are also very difficult to model. Yeah, I understand. Right. The other thing is, so a small aspect. So here you're looking at the velocity vector correlations, right? I mean, so
we are okay. So what we can you elaborate?
No. So these are so you are correlating the initial polarization vector with the final velocity maps, right? And somehow then creating this narrative.
Yes, exactly.
There's also another way of looking at the polarization fluorescence from the excited states and correlating from that, they're getting the alignment and orientation parameters. Is that not, I mean, I suppose your spectrometer allows you this.
Only the ions,
Ions,
so fluorescence we cannot do in this.
Okay, thank you.
Yeah, please wait.
Madam, nice to see your presentation. So, I used to take daily 3 injections in the COVID time. I'm in ICU. So
how sorry?
Daily 3 injections, ma'am.
You?
Yeah.
Oh.
In the ICU.
Are you?
Fine. So at the time, when they are giving injection, we have to put in a complete lay down properly.
Yes.
Slowly they are injecting. They are checking that is there any blood clot while the movement. So how it will be tested here now?
So so that is still so these questions actually we are also asking ourselves, because since last 2 years we are developing that, and there are many things which we need to really work on. So first thing is when we interviewed nurses and the doctors, I actually asked them that how do you feel when it goes inside. So everybody, the common answer was the pressure they feel. I mean, when they insert it, the pressure, when they try to insert, the pressure is different. When it is already inserted, that pressure is entirely different. And that is where we need to take the advantage of the technology, where we can actually put a sensor, the pressure sensor, which can actually tell us that this is, when it has already gone into the right place, the pressure is different, and then when it is going inside, pressure is different.
Yes, actually, nowadays they are injecting a high dosage antibiotic.
Yes.
When you start injection, it starts burning at the edge.
Agreed.
Then they're slowly injecting. They are seeing that, okay, are you paining here, any pain here, or any pain here? Like they are asking each and every moment that how you're comfortable there. So after 1 hour, you're in observation. If something goes wrong, there will be the other injection from this side. So I feel the same thing. Their injection here after 1 hour is burning like anything to me. So they started giving the antibiotic from here. So it take at least half an hour to get settled down. So in that case, and you're just in a machine, you're keeping the hand like this.
No, you can actually, it has, you can like, yeah. So yeah. we are trying to make it inside. We will have the facility. Yes. If the patient is lying down, it can actually go inside. You can actually insert your full hand there.
Yeah, because this type of instrument is required. Because most of the people, they're scared to do the injection in especially in the ICU section.
Yes.
The specialized people, no, they are COVID patient. I don't want to go.
Yeah. So this is,
if this comes under picture, so it is going to be rectified some problem.
Okay, so I don't want to really put, as of now, the hopes high. So the thing is, it will take another 2 to 3 years to come into the market, or maybe to give it to the trial, because it requires, to directly put into human, it is not justified. So it has to be tested multiple times, 1,000 times, 5,000 times, or lakhs times. If we are sure, then only it can be.
Yeah, thank you.
Ma'am, 1 minute. Please wait for the mic.
It is 100% the safe side, or any ethics are there. So, as of now, we cannot say anything. As of now, whatever results we have are on Phantom. On Phantom, it is doing correct. So we cannot say anything. Thank you.
Very, very nice talk, Vandana, and really fantastic to see how things you have built up. I have a couple of questions. Maybe you said it and maybe something it's very obvious, but I may be asking something very obvious. So there are also these medicines which are slow release, like for cancer they sometimes give you that they put an injection and then you know that it is there. So your thing will be also very useful for that. Are you already working on that?
So that this device will be useful for that as well.
Okay. And does it therefore, because some of those are actually given at closer to the tumor at different places?
So it will only be, so it is only for veins, because we are able to image only veins. If as long as it is vein, it is fine, because we are working in the NIR region. So because we have this deoxygenated blood in the vein, so it all the NIR gets absorbed there. So we are able to image it. As long as we are able to image the vein, we can do it.
But the veins just need not be on the hand; they can be in the different parts.
So then it is difficult. Near the heart and all, it is difficult.
Okay. So this what they call central vein, where they sometimes
so it is deeper. It is deeper inside, and that is, I think, below the ribs, right?
Yeah.
It is not possible because the NIR can penetrate up to 5 millimeter.
Okay.
No, okay. So when they do that, yes. And then I think they are ultrasound guided injections.
Yeah, no, I was asking because for some of the tumors, cancer treatment, they put it in this because they want it to mix in the blood quickly. They put it in the vein closer to the heart, what they call the central artery. Even some medicines, when they are like fighting sepsis or something, they put it there to give the IV. So I was asking there, and that is this main vein close to the this side. The second question I have is, anyway, so as you said, it's more useful for where you can see the things closer to the surface. The second question I have is that having shown that this technique is now, of course, is very useful, and you have demonstrated that it is working, and of course I hope it will get made into the product very soon. But what are the other things which you are looking at, or the next thing which you think can be thought of in this?
Okay, so we are also making, very recently we started this glucometer thing. So we are still at the starting stage. So we are now the idea actually came from one of my husband's friend. So his daughter actually has been having diabetes since very childhood, and she is being pierced all the time, and it's very painful for the father to see that, right? So the idea again started during the COVID time itself, but we could not pursue it because we did not have any resource. And resources in the sense, we did not have human resources that time, neither we had any equipment lying in the lab. So but the idea was there, so because we are scientists, we know that this physics will work. So we very recently, as one student we have actually put up, and we want him to work on that. So the idea is very simple. So the thing is, we have glucose, and most of human glucose actually is either L or S. It is not both. We have either L or S. I forgot that time I remember that. So then it has the Faraday rotation. So the more the glucose level is, the more will be the rotation. Okay, and then it is directly proportional to that. So you just have to push the light in, and then you see that how much rotation it is, and then calibrate that rotation to the glucose level. And then you don't have to prick all the time. You will have the thing on the screen, like the oximeter, if we can make.
Okay, so that's of course very good. So now that you have told me this, I have one more question. So are you really thinking along in the directions of being an entrepreneur? Because you seem to have a lot of plans.
No, I'm not an entrepreneur, because for that actually you need really a big push. I cannot make people work for me. That is not a quality of entrepreneur. So I can work for myself, but I cannot make people work for me. So the team which works with me, they are actually they are self-guided people. And it is not like that I am guiding them. So it's God's grace that they are there with me, they are self-guided, and they are working on their own.
I have a question. This is about that whole slide scanner that you had shown. We have worked on desiccation drying of droplets, including of, we tried with blood, but mostly on milk colloids. So what we found is using machine learning to actually recognize the patterns, because each drop is going to be unique, has really helped us.